All right, guys. Well, in this short video, we're going to talk about how do you find the derivative of a series. So if I give you a series and ask you to find the derivative, for example, so what is the derivative of, let's say, the series from 0 to infinity of x to the n, which is the series, the geometric one we know, 1 plus x squared plus x cubed plus x to the 4, plus so on, and then my general term is x to the n. Like, how do we take a derivative of that? Okay, now, basically what you're going to do is you're just going to take the derivative of each term. And just remember, because we're taking a derivative with respect to x, what that means is n is a constant, which makes sense, right? Because n is 1, and then 2, then 3, then 4. Each individual term, that n is not changing. So when we take the derivative of these, the derivative 1, 0, derivative of x is 1, derivative of x squared is 2x, 3x squared, 4x cubed. So when I take the derivative of this term with an x to the n comes down. So the n comes down, and then we subtract 1 from the exponent. So it's nx to the n minus 1. That's how we take a derivative. So if we just do the general term, it's just a series of nx to the n minus 1. Okay, so that's how we can take the derivative of a series. Just take the derivative of each term. Remember that n is a constant. Okay, let's look at just a couple more examples. Suppose we have to take the derivative of the function of x, f of x equals the sum, 1 to infinity of 4n squared x to the n divided by 2 to the n. What I want to remind you guys is that everything but x is a constant. So all the n terms are constant. And what that means is you can pull them out. So you can treat all of these guys right here as a constant and just take the derivative of x to the n. So when we take the derivative of this, you still have the sum 1 to infinity. You still have a 4n squared over 2 to the n, but now you multiply by nx to the n minus 1, the derivative of x to the n. If you want to get cute, I mean, you could combine that into like 4n cubed over 2 to the n times x to the n minus 1, but it doesn't matter. Nothing else changes. The bounds of series don't change. The constants don't change. You just take the derivative of that x to the n part. Okay, let's look at one more example. So suppose now what we're going to do is we're going to go ahead and take the derivative of g of x, which is the series of 3 times x to the 2n plus 1 divided by 2n plus 1 factorial. There's going to be a cute cancellation here. Let's say this is the sum 1 to infinity. Okay, so when we take the derivative of this, again, anything without an x is constant, so leave that in front. So that's just going to be 3 over 2n plus 1 factorial. And we take the derivative of x to 2n plus 1, that whole power comes down. So that's 2n plus 1 times x to the, okay, and when I subtract 1 from the power, you just get x to the 2n. Now, a lot of the cool kids are recognizing there's some cancellation here, right? 2n plus 1 factorial is just 2n plus 1 times 2n factorial. Remember, you just go down by 1. And then you're recognizing, oh, I could just cancel those terms. So you just end up getting this sum of 3 times x to the 2n divided by the 2n factorial, because you could just go down 1 and kind of cancel the factorials. It's a very bad 2. Okay, so that's how you take a derivative of a series. Anything without an x is a constant. Just leave it in front. Take the derivative of the x part as part of the series. Okay, thanks for watching, guys, and I'll see you in the next video.